driving the car. Nice job. All right, Jackson, this is you. Nice throw. You throw good, Jackson. Oh, wow.
You're getting them.
Man, we got so many. Man, we did a good job. Oh, nice job. Addicted already. My son and I are playing foot golf for the first time in our entire lives. So now we have to try to figure out exactly what we're doing. And we have to kick it down there somewhere. I'll probably kick it over in this area somewhere. He'll probably kick it down there. So, hey, look, there's our cheering section. Here's the problem. There's a large bush in the way. I'm probably going to hit against the bush and land right there in that sand. Andrew's a little bit closer, but I have to make it to the yellow thing on the other side. So good luck with that. Kick the foot golf ball. All right, I'm gonna take my return and supply probes and put them inside. And the closest outlets, P51 is on. And we have it hooked up to the liquid line and the suction line. I always like to take the old part out first, and then I'll put the new part in. If I can leave the wires attached, that way it's easier to go from one to the other without making a mistake. Good tip, after you put this back in here, we call this. Spin it, make sure you're not hitting anything, just to make sure you don't have a surprise when you start the unit back up. That'd be bad. All down underneath the air conditioner. There is no bottom on the hood, which isn't too critical since it's foamed up, so that's not a really big deal. But I did notice that the high voltage was left exposed down here. Welcome to HVAC Shop Talk, everybody. Hope everybody's having a great evening. I know it's Saturday night. We're all watching HVAC stuff. What a bunch of nerds we are. What a bunch of nerds. I was sitting here getting ready for everything, and I was noticing, I should show everybody this. Well, let's say it's a surprise. I always call my meter the fluke-like meter. If you watch the videos when I go out into the field, you'll see I'm using this, and I can't remember the name, but I think it's like Meturk. I always call it fluke-like because a lot of people respect fluke highly, and seeing some non-fluke meter that I refer to as fluke-like, they really take offense to it. And I'm going to just be honest, it's kind of amusing sometimes because obviously I don't compare them as equals. So I have another one of these things. Actually, let me be honest, a company on Amazon sent me this meter so I could test it out for them. Now, I'm going to show you the meter because I've set the stuff up so I can do that, and I think you guys are going to enjoy this. Here, let me switch cameras here, see if this will work. All right, here we go. So, you see a little bit of my gear. Oh, the shroud is back, the wizard, okay? So, this is I don't know how to say this. I'm pretty sure that's not from the good old USA. I'm positive. It's like Kawitz. I'm not sure. I feel stupid for even trying it. It's a clamp meter. They're like, will you try this thing out? I was like, I will absolutely try this thing out. It better not kill me, is what I said. So, look at this thing. It's tiny. Now, I'm not a giant or anything like that, but it has, I'll go ahead and run this through. It has capacitance. It has a diode test, ohms. It has tone for a complete circuit. It has AC and DC voltage. It has a 2 amp, 20 amp, and 200 amp setting. I am going to take it into the field because I'm just one of those guys that's, spendthrift, if you will. I don't know. Let me see if I can zoom in on this a little bit more. Yeah. So you can see this thing a little bit here. It is the HT200B. Now, you guys might say, Zach, you should never use that thing in the field, but I'm just crazy enough to try it. I don't endorse. I'll tell you what I really don't endorse. No matter what happens with one of these meters or whenever you use it, The weak link, and someone online said this, are the leads. The leads are always horrible for these things. They're like the worst things in the world. What's ironic is I think the best leads that I ever used, and we can get off here, the best leads that I ever used were actually Fluke. And it was a set, and it was, I'm trying to remember, it had 3 components to it. It had like the wire part of the lead, and then it had like alligator clips, and then it had another like just regular test lead. That set cost $80, which is twice as much as this meter cost. But you know what? It's like the best set of leads I ever had in my life. So it would be kind of odd to put that set onto this meter. It would be kind of strange. I used it with Field Piece and with the actual Fluke 902 FC, which I thought was it was a fantastic meter. So I want to say hello to the people in the chat. Hello, Hughes Man, who says, I bet that Virginia Tech trip was cool. It was very cool. It was a lot of fun to go out there. We're taking my son to as many of the colleges as we can, especially the ones that are within a few hours. He went to Boise State, which wasn't a college trip per se, but we did go to Catawba College for that, or as I pronounce, Catawba College. And then we got to go to Charlotte, so that was a lot of fun. I've never actually been to Charlotte. I live 3.5 hours away from it. We went to Virginia Tech because something I didn't know was that Virginia Tech actually has like a strong military component to it. It has a cadet corps on campus. There's a section of the campus, and it's called Lane Hall. It was in that video that I showed here just a second ago where he's standing in front of the student hall, and then it has some of the cadet residence dorms around it. It's really, really cool, and you never would know that Virginia Tech actually had that sort of thing. Virginia Tech, Texas A&M are both like that, and I never would have known that. So we wanted to visit those schools because he's seeking a career in the military, and we're going to visit the Citadel, which is in Charleston, South Carolina, next month. So that ought to be fun too. And another fun thing, I got to meet Curtis Bowers, which is a listener. He's been interviewed on this show before. He's a business owner that's up in Blacksburg, where Virginia Tech is at. We had dinner. We had a lot of fun. Exactly like the interviews go, with us laughing and carrying on, it's exactly what happened. It was a seamless transition from the digital world to reality. It was a lot of fun. So, but like I was saying, Hughes Man, welcome to the show. You might see Hughes Man on this show coming up soon if I get my scheduling into gear. Old Handy Luke says, I wonder how long the meter will last. I guess only time will tell, but I would not suspect as long as some of Field Piece and Fluke's meters. I wouldn't think so. Tony Reyes says, howdy. And we also have Entrepreneur Box, Thomas Leck, and we will get to your questions too. I want to really put it out there, guys. Jose is from Samsung. We're here to talk VRF tonight. Give us any sort of question you have on VRF. I really want you guys to supply a lot of the questions that we answer out here and we discuss, because I'm just like you guys. I'm learning about the stuff. I have a very limited knowledge of it. Basically, my knowledge sits right outside my house over there, and whatever mini splits I put in over the years, which includes Samsung, and Samsung, I guess at the time, Quiet Side, which were the same thing. I can ask Jose about that. I think they were the same company for a while, or one of them owned the other one. I don't know which way it went. Put in some Daikin units. We put in Fujitsu units, just all across the board. So I've done those type inverter-driven systems. I don't think I've ever put in a mini split that wasn't inverter. I know there were some that were single speed. I remember them a long time ago. We actually fixed one because it was, you opened it up and there was no board. It was just relays. It was kind of funny. It was just like a regular unitary system. So Old Handy Luke says their phones rock. I don't know if that's the same. Jose can answer stuff about your Galaxy phone. Probably not. But just keep it VRF. We might get something done there. Greg Meadows, what's happening? Good to see you here. So what I'm going to do here is I'm going to go ahead and bring in Jose, because we had a couple of things that were in the chat up here at the top, and we'll go ahead and highlight those and talk about those, and hopefully that spurs some more conversation. If you guys stop asking questions, I'll just, in my ignorance, come up with as many as possible, because there's plenty, because like I said, I am full of ignorance. So without further ado, this is Jose de la Portilla from Samsung, and welcome to the show, Jose.
Hey, good evening, everybody. Thanks for jumping in, and I gotta say, Zach, thanks for the chance to come in and be part of the show tonight. I'm really looking forward to our conversations.
Absolutely. And this show, and I'll remind everybody else, this show becomes a podcast later, so what you listen to now you can actually listen to later as well in your truck, because sometimes it's hard to catch the YouTube live where you can ask your question. So take it to work with you as well. So it's a 2-for-1 here. You can listen to it twice. Hey, really? Listen to it twice. That'd be the most help right there. Listen to each one twice. Let's just keep going. Each one twice.
There you go.
All right. So, Jose, for before we get into the questions, why don't you just give us the brief rundown? I know you've been on the podcast before, but just let us know what you do and give us what I call the 2-minute history of Jose.
You got it. So I work for Samsung. I've been with them for 4 years. I'm the national training manager. As such, I'm in charge of technical training, install training, service training, sales training, business training, engineering training, any kind of training. That's what I do. How I got to Samsung is I started my career in HVAC in the service side of things. I actually started as a maintenance tech, worked through trade school, became a service tech, did service for 6-7 years out in the field pretty consistently. Ended up getting swooped up by Carrier as a tech support guy and a technical support guy out in the field. Did that for 10 years with Carrier. And in that time, started training. From that, I got hired by Lennox to be in charge of their technical training. So that was a really unique position because it wasn't in charge of training on Lennox product. It was training Lennox contractors about everything about air conditioning, how to check temperatures and pressures and how to, do maintenance, just everything technical about it. And then from there, I started doing business training, sales training, and even some business coaching. And that's where Samsung came in and swooped me up. So I've been in the business now it's going to make me feel old, 29 years. And it's just been the best thing I've ever done. As a kid, I would have never thought HVAC would have taken me to places it has, but it's been amazing.
When you were first starting in the trade, what did you envision the future was going to be like? Did you think I'd work here for a while, then I'd do something else? What did you picture?
I mean, honestly, I thought I'd be doing service my whole life because I'm a very systematic person. I love just digging in and tinkering, and I thought I'd be doing that forever. And then it just, the man upstairs unfolds certain things at the right time. And as I went through and was doing service in the field, I thought I'd never leave. I got an opportunity to do service, but for an entire region. And instead of turning the wrenches, telling people, hey, try this, do that. And man, it was amazing because I got to experience the world from some of the best roofs in the world, beautiful sunrises and sunsets, working on complex machinery. If I had never taken that gig, I would have never worked on a centrifugal chiller. And now I have, and so it's just every time another opportunity opens, I've jumped for it and I've learned so much. It's been incredible.
Well, that's interesting that you mentioned some of those extra things that we get, and I remember those moments. And when you said roof, I remember the exact roof. It was a sports medicine building where we did there was 16 or 17 split systems, and we'd go up on the roof where all the condensers were lined up like everybody's seen them lined up before. All of them were Carrier, except for the ones that got changed out to whichever contractor's preference it was. And every day, and this is overlooking downtown Wilmington, the sun would go down in the distance. It was almost a pleasure to be working a little bit later because it was a beautiful view. And it was just a great place to work. And those are the little things. I agree. I think the man upstairs, hey, you're in the right place for that. Man upstairs is definitely guiding us through this stuff.
Absolutely.
Just before we get to a question, I'll go ahead and I'm going to ask you, when you were in the field, actually localized in the field doing service, did you ever have to get into any of the VRF or variable speed stuff firsthand?
When I first got in the field, again, I'm probably dating myself a little bit here, but when I first got in the field, the first VRF type thing I worked on was actually a Carrier mini split. And it was cooling only. It wasn't a heat pump, but it was inverter driven. And man, I'll tell you, when I opened it up and saw all those control boards, it blew my mind. It was just amazing to see that. And I thought, you know what? These are kind of cool, right? Because I could see that, hey, they're niche. But to be honest with you, man, when I saw that first one, I'm like, it's never really going to take off in the US. We like our furnaces. We like big duct work. And then, 30 years later, they're chipping away at the market like every day.
I remember the same thing. I don't know what year it is that you're referring to, but I remember in the late 90s, we were doing a job, and these were energy efficient homes in Wilmington. And they were talking about mini splits. And at the time, we didn't do any mini splits. We weren't really familiar with them. And the guy was saying, these things are the wave of the future. And I was like, sure they are. Why do you think? Because in Japan, like I went to Wikipedia, which is a foundation of knowledge, and I read that this variable speed technology was invented by Daikin back in like 1982. So in 1982, I'm talking about 1999, which is almost 20 years later. What's taking it so long to catch on here as opposed to there? What's your opinion of that?
Well, if you think about overseas, the way they the way they construct their buildings is completely different, right? So I've been to Korea about 6 or 7 times, and concrete floors, concrete walls, concrete ceilings, really modern designs, very minimal spaces, though. If you look at a home overseas, and whether you're looking in Southeast Asia or Korea, or you're looking in, the European market, there's not a lot of room. They don't have quite the real estate that we do in the homes and the buildings out here. So where we have the room for all this ductwork and everything, they've never had it. So they had to come up with alternative solutions. And then also got to realize that as bad as we complain about our electrical infrastructure, man, it's pretty darn good to compare to other countries. So they had to come up with ways to conserve energy, and they jumped on it because they had to. They couldn't keep up if they didn't. And so we've never had those kind of issues here. We've never really had homes that we didn't have room to do stuff with. I know it seems like it when you go out and service it, and some engineer shoves that furnace up in an attic or in a closet, and you can't even get your hands around the sides. But we've really not been constrained like the other parts of the world have. And we've never had a grid that was so faulty that we couldn't at least run unitary. So I think that's a lot to do with it, Zach. It's just the difference in construction, utilities, and all of those things out there have completely changed the need for it. And we just started adopting it as we're trying to get more green. And as we are shoving more houses in a lot, we are running into some space constraints now.
That makes a lot of sense because thinking about we'll call it the old world, where they built things hundreds of years ago, so all of their cities are built around cities that were built not even knowing that air conditioning was going to exist at any point.
Yeah.
So that makes a lot of sense. So you're saying that they were kind of steered right into it by necessity, and we're now choosing it for efficiency.
Yeah, that's the way I look at it. And just like anything, I did a presentation on mini splits and VRF a few years back, and we talked about it being a disruptive force. And when you think about disruptive stuff, anything that's disruptive in nature usually starts off with a bad reputation, right? If you look at Netflix when it first came out, it was not everybody's favorite. I got to mail a DVD. I got to wait for it to come back. If the mail doesn't get back fast enough, I get these big, huge fines and fees. But it became a disruptor because it took all of that negative press, all of those complaints, and it just kept morphing into something better and better and better. And I look at mini splits and VRF, it's the same thing. When the first mini split came out I ever worked on, man, Zach, I thought that thing was the biggest piece of trash I'd ever seen. But they've gotten better and better and better. And that's what I think is making it a little bit more palatable. Also, that since technology has jumped so much over the last 20 years, the cost to build them has come down pretty much. So you're seeing a lot of more cost-effective methods out there. And really, when we put up you go up to a nice home that's got a 5-ton, inverter-driven unitary product with ductwork, and you come in with a VRF system with 15 air handlers instead of one big furnace, it's really not that far off price-wise now. And it's giving the end users a little bit of a chance to really say, okay, what is my SEER? What is my EER? What is my COP? What am I really saving? And how many rebates can I get? So it's really taken the challenge or the bad taste people might have away from it, because it's more of a cost-effective solution now than it's ever been.
And I would like, at some point, we'll talk about reliability, because that was my concern as well early on in the process. I'm building an office outside. I'm going to move where I'm at right now, which is the fourth bedroom of my home, and go outside here shortly.
Yeah.
Shortly if I finish it, and it'll be heated and cooled by a mini split, and I have the mini split out in the building. There'll be a video next week probably about that, and it's 9,000 BTUs just because that's the smallest one that I had at my disposal. I know there's like seven. Daikin's have 7,000. What is Samsung's
Yeah.
smallest?
We go down to a 5K on one of our systems.
Really? Oh, that's interesting.
Yeah.
Okay, 5K.
Yeah.
That
Little
is-
one-way cassette, you got a 5K matchup.
I really like that because even the 9 in my building's 140 square feet. It's going to be insulated well. It's going to be sealed well. 5K would have been fine for that building.
Yeah.
So that's very interesting. Okay, very cool. Maybe we can talk about that a little bit later too. But I looked at the efficiency little yellow sticker, and it's 25 SEER and like maybe 10 or 11 HSPF because of the heat pump, and it's just amazing that you could have something that's 25 SEER when coming up at the same time period in 1999, I think it was still you could put in 10s, if I'm not 10 SEER, and it's just switching to 12. Maybe it just switched to 12. So it's quite a perspective. It's twice as efficient BTU per watt. That's pretty nice. That's come a long way right there.
Yeah, and the thing to remember too is if we look at SEER ratings, remember SEER's based on the worst day of the year, right? It's based on AHRI conditions at SEER rating. I wish the residential side would let us publish EER, which takes into consideration part load performance, because then your energy savings would like quadruple, because 99% of the time, if you're looking at that mini split, it's going to be in part load. It's not going to be fully loaded. So you're going to save even more than you realize. SEER it's frustrating because of legislation. We can't publish anything but SEER on a residential product, but EER is a much better store.
It's interesting that you mentioned that, because I remember years ago going into East Coast Metal, and at the time they sold they're a Goodman place, so they were selling Daikin mini splits, and that's exactly what they had said. It was like a 23, because I put in one of the 23 SEER, and this is several years ago, and they said it's a shame we can't take into account where we're at as far as compressor speed at various parts of the year, the ramping profiles, because it would change quite a bit compared to something that's just on off.
Yeah.
It says they just ignore some of what is the greatest advantages of it when they calculate it, which goes right along with what you're saying, which is interesting.
Yeah, absolutely.
Do you guys publish your own just like an EER report that says this is what we run at this sort of temperature? Because I guess it varies from place to place, though, depending on the climate.
Yeah, EER looks at some standardized conditions, just like SEER does, but then it has a factor built into it for part load. And I forget what that percentage is, but I think it's somewhere around about a 0.70 to a 0.75 something, which says that roughly 70% of the time you'll be running less than full load. And that's where EER comes in and gives you that calculation. It's really similar to SEER, just with a multiplier for what you would see on part load.
Oh, very good. It'd be neat to compare, because I remember that from so many years ago. So without further ado, let's get to some of the questions, because I haven't even scrolled down the chat and there might be more.
Yeah.
So I'm going to put up Clint's that came in before the show actually started. It is saying latent heat removal. I know most of the units I see are oversized, which doesn't help. Now let's talk about latent heat removal with these VRF systems. Just in general, give us a rundown of how they compare. Let's start with how they compare to something single speed, first of all.
Okay, so if we're talking about latent heat removal of a VRF driven system versus like a two-stage system, you can have, when they're sized right, much better latent heat removal, because when they're sized right, Zach, these things are not going to shut off. I mean, they're going to run 90% of the day because they're sized appropriately. And of course, the longer we keep the air in contact with the coil, the more and more humidity we're going to remove. So when you look at it in comparison, there's no other product that's better at removing moisture than anything inverter driven. The caveat there is as long as it's sized right. And Clint hit the nail on the head, right? when we're talking about VRF, whether it's a commercial VRF unit with like 128 indoor units, or it's like a multi-zone mini split where you got 5 indoor units and 1 outdoor unit, what people do is they size them based on ACA Manual J worst case condition, but they don't stop to look at the individual zone loads. So they look at a block load instead of peak loads. So maybe the eastern side of the house has much more heat gain in the evening and the west side has next to none. When we take that diversity into play and we say, okay, I won't need 100% capacity at any time, and I use a diversity rating of maybe like 115, 120% diversity, meaning I have 120% more indoor unit than I do outdoor unit, then those things just run like a champ. But the problem is, you know how hard it's been for people to get to learn how to do a standard load calc when they have to do one where they're looking at individual zone loads and sizing to the zone load and then picking an outdoor unit, which is a little bit different. People get confused. And so they take a 4-ton out, they put a 4-ton in, and you know that original building probably never needed a 4-ton to begin with. And so now the thing tries to throttle down as low as it can, but it shuts off. And then that humidity gets back into the space, right? If we make a coil cold and wet, and then we shut off and we don't turn back on for another 5 minutes, all that humidity is going to re-evaporate or aspirate back into the room, and you've got humidity problems. But when they're sized right and you take into account that diversity, meaning that not every room needs air conditioning or heating at the same time, and you can pull heat or air conditioning from one room into another, and you don't need the outdoor unit, you size them right, man, they work like a charm. But Clinton hit the nail on the head. If folks are going out there doing a standard Manual J and not thinking about the differences in the zone loads, they're going to run into challenges.
Now, listening to that, I'm thinking to myself, and I'm thinking about how I did Manual J's back in the day. A lot of it was block load. But even if I did a zone load, let's say I did every single room in a house and didn't separate it into, like, nighttime, daytime, or some common zones. If I did every room in the house, the way it was done before, we would still do it at the same peak time. But if we did Manual N, which was the commercial load book, we would do, it would take into so many more factors, even the shading of the windows, the percentage of window shading. There was so much more to it. It sounds like we need to adopt like the Manual N strategy if we're going to do something like VRF, so that we don't, if we needed a 3-ton, even instead of a 5-ton, with all the load shifting across a building, you could switch maybe a ton and a half in that situation. It's big.
Yeah, real easily. And what I've done, and when I've done some I haven't done the big VRF stuff, because usually the big VRF, we have plan and specifying engineers that do that, and they run their own load calc software. They don't deal with ACA at all. But I've done residential ones, and what we've done is we've ran the Manual J, and I've ran a Manual N, and then we look at the individual room loads and add those up. And I'll tell you, it's surprising, because 9 out of 10 times when I add the individual room loads up and I account for what ACA has as the AED, the adequate exposure diversity, if I find a building that doesn't have adequate exposure diversity, that's when I jump on the ability to use that diversity for mini splits. Because, okay, so adequate exposure diversity means that the building has the same exposure. The east, the west, north, and south, they all have a similar exposure, right? Meaning they all get about the same amount of heat. Realistically, most homes don't have that. My house, I'm in the country, I'm on 2 acres. I don't have a neighbor to the left or the right. So the east and the west side of my house are completely different night and day with their load calculations. Because the, sun rises in the east, the front half of my house, it never has load. It's always chilly there. But the back half at night, where the kids' bedrooms are, that bakes. So what do you think they did when they sized my house? Well, they went off of the worst case condition, which was the western exposure. If they would have done a full Manual J and saw that I lacked adequate exposure diversity, meaning one side of the house calls for more than the other, and they flipped it to a Manual N style, or they looked at the block loads individually, they wouldn't probably pick the same size unit. And if they had mini splits, they could have gotten away with it. But with unitary, you got to put in the system that's going to cover you on the worst day of the year or, running service and stuff like that, if it doesn't keep up on the hottest day in August, no matter how it works the rest of the year, you're in trouble all year long.
Yeah. Yeah. You're going to get phone calls going out.
Yeah.
Interesting. I had something I was going to ask you, then I got into the rest of what you were saying, and it completely evaporated from my mind.
Oh, I've been there. I feel that pain.
I know. I want so bad to remember now because I felt like it was going to be insightful, but I might have to abandon it because I have seen. Speaking of like the manual J's and manual N's, which I always did them by hand, which nowadays that would never happen because you have so many more inputs and it wouldn't work out as well. And the difference between, and I do remember my question now, so I'll get to that in just a second. The difference between like a northern exposure glass and an east or west glass at peak times, it can be 3 or 4 fold. It can be huge, depending on what kind of glass you got. If you have like single pane, which is horrible, east or west. So it makes a huge difference, and I think you're absolutely right about that. I think you could definitely cut down on the size of a unit, and that's why we can even cut down on the unitary size if we're doing zoning that way. Because you can take that into account. My question was, and maybe just get your opinion on, if you're putting like a VRF system, you want to put in, you have the Samsung. How many heads can you put in with a residential style Samsung VRF?
So you got to look at 2 different styles. Okay, so if you have what we call a multi-zone, and everybody makes one, Samsung, Daikin, Fujitsu, we all make multi-zones. That's where you have the outdoor unit, and then you have the indoor units, but every indoor unit's piping runs all the way back to the outdoor unit. All the high voltage, all the comm, all runs to the outdoor unit. On the Samsung world, I can put 1 4-ton multi-zone with 5 indoor heads. If I'm going single phase VRF, that's a different ball of wax, because the only thing different between a little single phase VRF and a full size VRF is the size, right? Instead of having this big, tall, mammoth condensing unit, you've got a standard 13-inch deep mini split looking condenser outside, but it's full-fledged VRF. Now, if I pop a 5-ton in there, I can put 10 heads on that. And if you think about it, if I'm doing 10 heads in a home, right, I can group common areas together. So I've been drawing this out on my house because I want to go and switch it out to a single-phase VRF. But I would take that, and I would take my master bedroom and my master bathroom and my master closet, that whole kind of master suite. And instead of putting in a ductless, I'd put in a small ducted unit. Now, those 4 rooms or 4 zones would be 1 ducted unit. Now I've got 9 more to choose from. So that means every other bedroom can have its own air handler. A bathroom could have a jump duct coming off of a bedroom that's nearby or an adjacent bedroom. Like we got a Jack and Jill bathroom between 2 of the kids' rooms. So instead of running a separate unit for that, I run a cassette in one bedroom, take a little 4-inch subduct, drop it into the bathroom. The bathroom's got conditioning now. The living room has a larger cassette. The office has a bigger cassette. And the kitchen and the living room in our home are that common, it's that open concept that they have. So the living room and the kitchen just have an island between them. So really, I put 1 good-sized cassette in there or 2 smaller cassettes to help with airflow. I'm still not anywhere near needing to have 10 full heads.
Let me ask you, you said ducted unit, and I'm familiar with some ducted mini split units. I say mini split. That's the word I use. That's roughly translated to anything that's not variable speed unitary.
Yeah.
They go up to 1 million tons. Nah, I'm just kidding. I'm familiar with like what I call a pancake air handler, which the large rectangular air handler. Does Samsung also have like a lot of people are using like a air handler that looks like the unitary style? Do they have that same pairing, or do they use just the pancake style, or is it one or the other?
Yeah, so I kind of broke up. My internet kind of chopped there, but I think I got it. If I'm wrong, tell me what I'm wrong. We do have like what we would call a pancake style air handler. That one's called our slim duct, and every manufacturer has one. It's maybe like 7 inches deep, right? Put above a soffit, put in above a ceiling. Then we have a little bit of a larger ducted unit, which has more static capability, where those little pancake guys can maybe handle up to like a 0.3, 0.4 inches of static. The next size up can handle like up to a 0.8 inches of static. But then if you want to take a home, right, and I have an engineer who did this in Florida, South Florida, where humidity really is an issue. He didn't want to change out his existing duct system. So he pulled out his big old square box train that he had on the side. It was like a 25-year-old train. It had the old orange compressor in it that just wouldn't die, but it was
Oh yeah.
eating up his energy bill. He ripped that out. He put in a 4-ton mini split condenser, not a multi-zone, just a 1-to-1. And we do make what we call a multi-position air handler or a vertical air handler, which just looks like any other heat pump air handler. He stuck that up in the attic. So what he had now is he had the fan motor on the indoor unit that could ramp up and down. Then he had the inverter-driven compressor that could ramp up and down with an electronic expansion valve that knew exactly what the superheat was at all the time, not guessing based on pressure drop and bulb temperature, actual true superheat. And that sucker put it in. He stuck it on there. He ran it in dehumidification mode, and he said his energy bill, just by changing those two out, not touching his duct system, his energy bill dropped 45%.
Now, let me ask you, and I'm going to put it up on the screen here. I'm going to share something, and you tell me if this is the correct air handler. And sorry about this. This is kind of a cheesy share looking. Is that, it's tiny. Is that
Yeah.
the one you're referring to? Okay.
Mm-hmm.
Now correct me, because I was listening to you. Did you say the metering device was an EEV that was located in the air handler?
Yes, well, okay. So two different ways. Let me apologize. If you're doing a 1-to-1 mini split with the ducted air handler, the electronic expansion valve is in the outdoor unit, right? So it's in the outdoor unit, and that's why you insulate both lines. But
Mhm.
if you're doing a true single phase VRF where you have the 10 heads to one outdoor unit, then the EEVs are at the indoor unit. That's the main difference. When they're 1-to-1s, the electronic expansion valves are still outside, but when you go to multi-zone, the electronic expansion valves are indoors. And that's because the superheat in zone 1 might be 7, but the superheat in zone 2, where it's got all that sun exposure, might be 12. And so it needs to know exactly in those zones. When we're doing a 1-to-1, we care about overall system superheat, so we check it outside.
Makes sense. That makes sense. Now, the multi-zone that has the line sets running all the way back to the machine, no matter where, it's multiple line sets. Now,
Uh-huh.
do those have EEVs for each branch? Is that correct?
Absolutely.
In
Absolutely.
the outdoor unit.
Correct. And I think that's probably 90% of the manufacturers out there. I know the big four, they're multi-zones, the EEVs are in the outdoor unit. There's probably a few that do something different, right? It seems like every week there's a new VRF coming out or a mini split coming out. I mean, my TV is made by Hire, and I was literally on a job site 2 weeks ago where they were putting in Hire mini splits. So I don't know how those ones work, but I'm going to say that 90% of the market, if you're doing a multi-zone, those EEVs are in the outside.
Okay. And actually, well, I'll save that question. I was going to go into like a branch box discussion, but I think we'll save that for a minute because that'll probably
Sure.
take like a couple days. And we have one question answered so far. And this, Thomas, this wasn't really a question. It's kind of a point he was making. VRF with heat recovery and heat recovery to hot water for domestic water, then add that free energy waste heat from the hot water to reheat coil, which is a lot right there. But I guess heat recovery, what can you tell us about VRF with heat recovery?
Oh, you know what? It's by far it's my favorite because I've done some homes where even a simple home that only had maybe a 5-ton or a 6-ton load, it had the need. The homeowners wanted to have air conditioning in some zones and heating in the other. The last one that I looked at, the biggest things they had was they had a movie theater. This is a big home. They had like an indoor movie theater type thing built in their house. And no matter what time of year, that thing needed air conditioning because you had the projectors, the screens, the audio, the LED lights on the floor, and it needed cooling pretty much all year long. And then their gym, their workout room, they wanted cooling all year long. The rest of the house needed heating. So with heat recovery, you get the ability to do both simultaneous heating and cooling. And how it happens depends on which brand you go with. What we do is we have what we call the branch box, or we call them a mode control unit, um, BS boxes, selector boxes that have different names. But you have this magic box that goes somewhere inside, and you put it over an area that people don't usually walk by because it's going to have solenoids and EEVs in it that are going to click, right? And then what happens is you send refrigerant to that branch box. And if it's got a unit in cooling, it sends liquid to it. The EEV expands it, drops the temperature, drops the pressure. It starts absorbing heat, comes back through the suction line. If you got a unit that needs heating, it sends hot gas to it. And now that hot gas goes into the indoor unit and it starts condensing, becomes a liquid, and travels back to the branch box. And within that circuit, essentially, I'm simplifying it very much, but the heat you absorb from one room can be absorbed into the refrigerant, put in the branch box, and then that heat can be rejected into the room that needs heating. So you're taking waste heat. You don't want it in this room, and this room does want it. Let's give it to it. And then that outdoor unit really only has to come on and run it at a low enough frequency to push the refrigerant around instead of making all the pressure differentials and changing the heat itself. Does that make sense, Zach, or did I complicate the hell out of that one? Because I think
I'm not confused at all, Jose. No, absolutely not. But don't ask me to repeat what you just said.
All right.
No, I understand, because we had talked about this previously on the podcast a little bit, and I was trying to grasp it at that point, how it worked. And I have made inroads, but I'm not there yet. Now, I just want to show on the screen, and you tell me if I'm right or wrong. Is this the box you're talking about? He's a busy man, everybody.
Yep, that is our mode control unit. That is ours. And the difference you see from ours versus one other manufacturer is that ours has 3 pipes going to it. And the other competitor, I'm going to just say their name because everybody knows who I'm talking about. Mitsubishi has 2 pipes going to it. And so how those branch boxes work is a little bit different between the 2 brands, but they're pretty simple, pretty straightforward.
And the simple gist is that if you have multiple heads, you can do multiple. You can do heating and cooling, and you're moving refrigerant. You're moving heat within a structure instead of inside to outside, outside to inside. You're doing it from zone to zone with this method.
Absolutely, absolutely. And I might be giving too much than what everybody wants to know, but everybody has questions about the 2-pipe, 3-pipe difference. So is it okay if I give a quick scenario about how 2-pipe and 3-pipe differ?
Absolutely. Do I need to leave this up on the screen? Will that help or no?
Yeah, absolutely.
Okay.
So if you look at our mode control unit, right underneath the word on the upper right-hand corner that says MCU, you see the 3 pipes coming in. What 3-pipe does is one of those pipes is always a suction line carrying refrigerant back to the outdoor unit. One of those lines, the little line, is a liquid line, sending liquid to a unit in the air conditioning mode so it can provide cooling. The third line for ours is a little bit bigger, or sorry, a little bit smaller than the suction line. That's the hot gas line. That's the discharge line right off the top of the compressor. And that discharge gas goes to whichever unit needs heating, and then it rejects its heat into the space, condenses to a liquid, gets subcooled, and goes back to the mode control unit. So you want heating, you get discharge gas right off the top of the compressor. You want cooling, you get liquid out of the condensing unit. So that's all that really that does. Does that make sense, Zach? I want to try to confuse our audience. Okay.
It does make sense. Now, are these a quick question before you continue?
Yeah.
Where are the metering devices?
Okay, so when you're using a true VRF system, this is where those metering devices are going to be at every one of those indoor units. Because we want to know exactly, if we've got 5 zones, we want to know the exact superheater subcooling in zone 1, 2, 3, because they're going to be different, right? Based on the heat load in the space, then that EEV is going to open and close, and it's always going to try to maintain the same superheat, but the heat in that room is going to change how much refrigerant's needed to give us that superheat. So in our world, we always want, I think it's 5 degrees superheat across an indoor unit, right? And what changes is if there's a lot of heat load in that room, that 5 degrees comes really, really fast. And so we have to push more refrigerant in. The other side of the building, it takes forever to boil that refrigerant. So we close that EEV way down and we push less refrigerant in. It's all based on how much heat is in that zone. And it's like putting a pot of water on a stove. If you put a pot of water on a burner at high, it's going to boil really fast and increase your superheat. You put a pot of water on a burner at low heat, it's going to take forever to create any superheat. So the EEV just controls that so that we can always have the right feedback, the right condition we need in each zone.
So if we have these heads, they have EEVs I'll just say heads, but let's say air handlers. They
That's
have
fine.
EUVs, and each one of them desires 5 degrees of superheat. Now, what I'm imagining, and let me know how wrong I am, not whether or not, because I know there's going to be a certain degree of it. If you have, let's say you have thermistors measuring suction gas temperature, and you're calculating superheat, and it's sending it back through the control wiring to a board, and then the board's communicating outside. And that outside unit is running through all of these temperatures and calculating what that EEV's got to be at, or the board on the inside does that. I'm trying to imagine how the whole thing works, and I'm going to make it super complicated for everyone out here. But if I can't understand how it works, it's like I hate being in the dark on something, especially if I had to work on it. So I mean, where's the brain of this thing is in the outdoor unit, communicating with these indoor units. What controls the EEV, the indoor unit or the outdoor unit, basically?
So everything basically is controlled. The output all comes from the outdoor unit, right? So that's the command, right? So what you get, basically you have a thermostat in each zone, and that tells me heating or cooling. So what that does is that sends a signal back to that mode control unit or branch box and says, this one needs cooling, change the valve this way to direct the right flow of refrigerant. So that's the first point. The next point is it says, okay, I need cooling, so I need 5 degrees of superheat. Here's my inlet coil temperature. Here's my mid coil temperature. And here's my outlet coil temperature. Of course, with a mid coil sensor, we know what saturation is. The inlet, we know the condition of the liquid refrigerant if we're in cooling, right? And then the outlet, we know the superheat. We can calculate that. It says, okay, I've got this many degrees of superheat. So the indoor unit board at this point says, okay, my superheat's high, my superheat's low. My indoor unit board says, all right, indoor unit, open and close. Okay, so you've got that control, the indoor thermostat, wired controller, wireless controller, whatever you want to call it, tells the EEV what to do, or tells the indoor unit what to do. The indoor unit then reads the EEVs and says, okay, open up, close down. But at the same time, that indoor unit is sending a signal to the outdoor unit saying, hey, this is what I'm doing. I have 5 degrees of superheat right now. The outdoor unit collects all that data from every one of the indoor units. And here's what a lot of people don't realize. We actually are controlling superheat and subcooling in multiple places. So, for example, just 5-ton unit, 10 indoor heads, right? Indoor unit 1 has 3 degrees of superheat. Indoor unit 2 has got 5 degrees of superheat. It's working on coming down. The outdoor unit has its own superheat. So typically, I mean, this is a rule of thumb, but typically at any given time, the outdoor unit has 30 degrees of superheat. 30 degrees of subcooling outside. And outside it has maybe 5 to 7 degrees of superheat. So it's always got a nice, huge column of subcooled liquid that it can then send out wherever it goes. The outdoor unit cares about the outdoor unit's superheat and subcooling. The indoor units care about the indoor unit's superheat and subcooling, but they're all talking. So if the unit has a huge demand for extra refrigerant, the outdoor unit knows, hey, I got 30 degrees of subcooling. I'm going to let that subcooling drop to maybe 25 because I'm going to shove some of that extra liquid inside the building. So, I mean, it sounds complicated, but it's all control logic. And Samsung, what we use what's called fuzzy logic. And basically that's could be anything, right? It's always looking at everything and it's changing its values. So, I mean, superheat, we say rule of thumb is 3 to 5. It might be 2, depending on the deviation away from set point, the amps of the fan motor and how hard it's working, which of course would give us a relation to the static pressure of the airflow. So everything's looking at it. It says, all right, I'll give you 5 degrees superheat if these 12 things are in this position. And if these 12 things change, then we're going to change what our desired superheat should be. So it's all based on what we call a fuzzy logic. Now, I will tell you this. Sometimes everybody's like, okay, it's a fuzzy logic. If you want to know more, you can go to our website, samsunghvac.com. We're very forthcoming with our literature. You go to the technical documentation section. You go to VRF. Ours is called DVMS. And you can download a book called The Sequence of Operations, and that'll tell you exactly what that fuzzy logic looks like. And it's going to be a bunch of if this, then that statements. If discharge temperature is this and saturation temperature is this, then target superheat becomes this. Unless amp raw does this, then superheat does this. And it's all written out there. If you really want to spend the time digging through it, you can. Or if you just want to say it does it a little bit simplified, you can do that as well. Long-winded answer, I know.
Man, that's a lot of information, Jose.
Yeah.
No, but no, that's good stuff. My questions as service tech in me, if you have a situation because of the load of a building collectively, like across the board, is like a low load, high load, will the outdoor unit make a decision based on the compressor's safety? Like if you have an issue, like you're trying to hold superheat at the heads, but let's say superheat's too high at the compressor, will it kind of override what's going on at the heads to save the compressor from having an issue?
Yeah, absolutely, Zach. And this kind of goes back to your office that you're building. I wanted to share something about that. These units, and almost everybody does it just about the same. By the way, Hughes, man, I love you had a few beers, so I'm operating on fuzzy logic as well. I love that. Thank you. All right. So these units will do the first thing. Their first priority is human comfort. It's their first priority. Their second priority, because you asked a question about reliability, their second priority is to make sure that they don't break. So they'll adjust things throughout the day so that they don't bust. And the story I'll tell, if you look at your office there, we provide, I think Samsung's got about a 48% market share in India. And if you've ever been to India or if you've ever just studied up on India, they have the absolute worst electrical grid of anybody. So our systems are designed that if the voltage goes below 123 volts, it says, okay, I'm done. We're going into protection mode. And if it goes up above 330 volts, it's like, wait a minute, I'm gonna blow something up. Let me slow down and go into protection mode. And voltage is just one thing. Amperage is another. Superheat's another. Freeze up is another. I mean, you talk about a unitary product, it starts to ice, it just ices. Ours ices, it says, okay, wait a minute. That evaporator coil's starting to ice. Let me open up the electronic expansion valve. And instead of having a 45-degree evaporator coil, let me make it a 50-degree evaporator coil so ice can't form. And then if the system corrects itself, nobody ever knows it had a problem. But yeah, it's going to protect itself. Its first goal is human comfort. But if human comfort starts to endanger the system, it says, okay, hold on, pump the brakes. I'm going to solve this.
Is there a way that it communicates that it's having an issue? Without having like a service tech plugged in to the machine, how does it communicate, hey, I'm in protection mode, there may be an issue that needs to be attended to? How do people figure that out?
Okay, so there's a few ways. First and foremost, if you have a wired controller, like you're not using a 24 volt thermostat kit, because we make those, right? You can use any thermostat, but you're using in our example, you're using a Samsung controller. Or if you're using Mitsubishi, you got a Mitsubishi controller, it's going to spit out a specific error code. And it may run, but it's going to be blinking a C103 or a C205 or whatever. And then the technician can open up their phone or their booklet. I say phone because what we've done is we've taken our mobile app and put every error code in our mobile app. So you can walk up and type the error code in and see a description. And I think on about 70% of them, I've got a troubleshooting video now too. So if you get a C205, you can click it. It'll tell you what it is. Click play, turn the phone sideways. A YouTube video shows you how to troubleshoot it. So you can do that. That's the first way. But if you're the homeowner, you got to call the contractor and say, all right, I got this weird code. Another way that some folks are doing it is they're putting in a building management system, even on their smaller homes, like an integrator. We offer one, it's called the DMS 2.5. And basically it looks at the system, looks at everything that's Samsung connected to it. And then you can go to any laptop and log into it with a static IP address and see what the system's doing. And you can see fault codes, you can see diagnostics, you can do all of that. If the homeowner doesn't go with that, or the building owner doesn't go with that, maybe they went with a BACnet system or a LAN system, We can still do the same through BACnet and LAN. We just put a little circuit board that converts Samsung protocol into BACnet or LAN. If they don't do that, then you show up with a laptop, you plug into it and talk. Or one of the things we're working on right now is an app that you would put on your phone, and you dial into a little black box that's connected to the unit, and you see everything that the unit's doing right through the little app on your phone.
Now, what units are you talking about? Now, does it go all the way into the single phase VRF? You're excluding these from what you're talking about. This is the commercial end. Which units are
No,
we speaking of?
yeah, our single phase VRF will do the exact same thing. So you can use that same service software. Our one-to-ones, believe it or not, even our little one-to-one 9,000 BTUs or 7,500 BTUs in the Samsung world, I can't speak for everybody, but in the Samsung world, I can take my laptop and plug into a 9,000 BTU condensing unit and see all the operational history all the way through.
Now, you say all the operational history. What all do you see? Do you see like a graph of pressures? Just for my own edification, so I
Well,
understand.
so when you log in the first time, our units, we have an EEPROM chip on them, which is a little circuit board. It's basically the SIM card of HVAC, and it records like 30 minutes at a time. So if I log in, I've got like a 30-minute black box of everything, and it's going to show me temperatures, pressures, superheat, subcooling, amps, blower speed, what's requested speed, all of those things. I can see all of that. And then if I want to troubleshoot it more, what a lot of our guys will do is they'll set up their laptop to it. Then they'll hit record through our service software. They'll let it record as long as they want to. And then they can play it back at any speed they want and look at, I mean, we're talking superheats, subcooling, evaporator temperatures, condensing temperatures, positions of every valve in the system, amp draws of the individual components, CFM that the fans are running, demand and actual. So you really, I mean, there's not much you can't see when you're dialing that kind of stuff in.
So let me. You said CFM. The fans are running. Okay, we have a variable speed compressor on pretty much everything we're mentioning here. Now, how do the fan speeds respond? Like if you have like this single phase VRF and you have several heads in your house, are the fan speeds going to intelligently change, or is that something you just set and the compressor is variable, but the fan stays wherever you set it?
You know, Zach, that's a great question, but it really depends. And the answer is it depends on how the homeowner sets it. So if the homeowner decides, you know what, I want high speed fan because I need that air blowing on me, and they set it to high, they're going to get high speed all the time. If they set it to auto, the system's going to say, okay, you know what, I'm approaching that target superheat. So as I start to stage down my EEV, let me slow down the airflow too. So it just depends. If the homeowners decides I want low, medium, or high fan speed, or some of our units have low, 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 medium, low, high, medium, low, medium, 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 medium. So they have hundreds of speeds, or a bunch of speeds. If the homeowner decides a speed, they get that speed. But if they go to auto, they get whatever the system thinks is the best fan speed for it.
Now, I'm going to assume that auto is where it should be left. Is that reasonable that you should just leave it on auto and that would be the best for efficiency and load treatment?
Yeah, absolutely. The only time I see auto being a challenge is like Clint said, if the system's oversized, and then what we really need them to do, if we can't change the system out, but it's just a little bit away, what we do is we change the unit mode from cooling to what we call dry. And dry is essentially it's the Korean term for dehumidification. So it slows the fan speed down, and then it makes sure we can get humidity out. Other than that, put it on auto, let the system run with it and do its thing.
That makes sense. So I would assume that if you had to set it on dry, it's because an error in design was made and you're compensating for it.
Yeah, that's one way that happens is it's a design flaw and you're compensating for it. The other reason you sometimes see dry kick in is the home just didn't take into consideration the humidity that's creeping into that house. Maybe it's not sealed well, or maybe they're doing the stupidest thing in the world. They're putting a house in over a non-sealed crawl space, and all that humidity, that ground source humidity, is just evaporating into the space. And if that's the case, if the system wasn't designed for that, because most of the time, or a lot of the time, that kind of infiltration or humidity gain is overlooked in those areas, right? And that's where you're compensating for it as well.
I feel really bad. This is what I do in this situation. I'm not going to say which crawl space that I have. Okay. Uh, so is that, just curious, when you have people call in and say, this thing doesn't work, man, it's humid in here all the time. Is that pretty common where they've set it up in a location where, you designed something and didn't take into account that you had a crawl space humidity problem, or the windows aren't the windows? Is it usually like a manual J or a design issue when people call in like that?
A lot of times that's what we see. A lot of times we see that they didn't do the design right. And as well as I do, if the design isn't right, nothing's going to be right. So that does become a challenge. I'll tell you this though, I have seen these design problems worse in areas with basements more than crawl spaces. And that is because in a lot of the areas that have basements, they have a lot of humidity in the basements. And I'm talking Michigan, Minnesota, up in that area there. I didn't know it until I traveled out there that they put sump pumps in some of these basements to suck groundwater in that starts to rise up in the mechanical room.
Oh, yeah.
And if that's the case and that's not considered, even a unitary product's going to say, you know what, I'm done. I can't do it.
Oh, sure. Yeah, I've actually dealt with, oddly enough, here in North Carolina, I have one customer that had a basement. That's exactly what the problem was. There was a huge humidity issue, and it was always filling with water. I actually had to change out the sump pump.
Yeah.
Jack of all trades. Yeah.
Oh, yeah.
It's bad. That's what HVAC is, right? It's one of the appeals of it. We do electrical. We do actual HVAC, the actual treatment of the air. We do some plumbing, the drain, loose plumbing, I guess. It's still the same idea.
Yeah.
Water goes down.
That's right.
That's why it's the best trade.
Absolutely. We've got to know a little bit about everything. And I took a training class from a guy named Jack Rise, who works for ACA, and he taught the load calculation training. And I heard it best. He said, the problem is we do everything in HVAC, and there's all these targets, right? We have target humidity and target airflow and sealing in the house. We've only got one bullet in the gun. We sometimes can't hit all those targets. They're not all going to line up and give us a perfect place. So I thought that was real insightful then when Jack shared that.
Yeah, I've heard of him. He's a very intelligent man, I do believe.
Yeah.
He's one of those guys, you always hear about. But it seems like, okay, if we're dealing with especially variable speed system, that should hit the most targets of any system theoretically that you could possibly put in. Something that, and to me, that is reliant on the fact that you have it in, let's say, the auto mode, where the blower and the CFM is going to match match through some algorithm or something what the compressor is putting out. That seems like that is going to be the ultimate match to your load that you could possibly have.
Yes, absolutely. And can I geek out for just a second and tell you some other thing that's really cool?
It'd be too late to stop doing it.
All right, cool. Okay, so let's say that you have a mini split system and you put a cassette in one area, but the building has 10-foot ceilings, right? Maybe they've got the big vaulted ceiling. Seen a lot of houses. I'm sure you've seen a lot of houses with 10-foot ceilings now. You got a cassette up at 10 feet. Well, the temperature at 10 feet is not the same temperature at the 5-foot zone where we live, right? Our occupied zone.
Mm-hmm.
So you can get accessories. And one of the accessories you can put on a cassette is a motion detection sensor. So it does a couple things. One, it looks for motion in the room. It says, okay, there's people in the room. I'm running. People leave the room. I'm setting back. It's the first thing it does. Second thing it does, it says, where are the people? Are they on the left side of the room? Okay, then I'm going to blow most of the air to the right so they don't have velocity on their neck and they're cold. And then if they move, I change the airflow. Right? But then it has an infrared thermometer built into it that shoots the floor temperature. And it says, okay, at 10 foot, I'm 75. At 5 foot, I'm 78. I'm not getting the air down far enough. Let's change the airflow and throw it directly down a little bit more so we can compensate. Now, you want to talk about the ultimate system trying to keep you comfortable and hit every moving target? Add accessories like that, and it's like, bam, you got it all.
That's pretty high-tech stuff.
Yeah.
For some, service tech brain right here. Motion detection. You walk into a room, it senses that you're there, and it goes into the occupied mode, so to speak. So you leave a room. How long until it sets back? Because it's not going to do it immediately. Like you walk in and out, it's going to go switching back and forth. There has to be like a delay in time, I would think.
It is, and it's completely customizable. So you can decide, all right, if there's no occupancy for 10 minutes, do I set back? If there's no occupancy for 20, I mean, it's completely customizable. But then that fuzzy logic we talked about, it actually learns. So you set it up and you tell it initially, okay, 20 minutes, I'm out, go to setback. I come back in within 20, 30 minutes, go back to normal. It starts learning and it says, okay, well, Jose told me to wait for 20 minutes and then shut off. But what I'm finding is he comes back in at 17 minutes. So maybe I need to wait until 25 minutes to set back. You don't do a thing to it. It just starts learning your pattern. And it says, okay, he told me to wait 20 minutes, but this is what's really happening. So I'm going to go into setback earlier or later, depending on what the learning pattern is.
Interesting. Okay, following up on that, we have a question, and I know there's another one up there from Hughes Man. Just hold on one second, Hughes Man. Greg Meadows says, "What about motion detector at night in the bedroom shop talk? People go to sleep; they're no longer there. You know what I'm saying? It doesn't sense them any longer."
Yeah. Well, actually, okay. So there's a couple different ways it does that. Remember, it's got an infrared thermometer, so it's checking temperature. So even at night, it does that. But you could also, if you're saying in the nighttime, you can change that. So you could say at this time frame, ignore the setback. It's all customizable because it's fuzzy logic. And the cool thing is all this software is written. You decide what you want to do.
Is this through like the room stat you access all this, or you do it through an application?
So you can set it up on the room stat. Some steps are a little bit more complicated because you got to go into these advanced menus. So to change the timing on this or to turn it off, you might have to go into advanced menu, then go into installation option code 2. Then you might need to change segment 7 to a 1 instead of a 2. Or you take a laptop computer and you change every parameter at one time. So it just depends on how you want to do it. If you're there and all you've got is the room thermostat, you can do that. Click it, right? You can do the advanced coding through a wireless. You can do the option coding through a wired controller. Or if you're the service tech and you got a laptop, you just read the manual and know everything you want to change. You open up this code string that's about 25 numbers long. You change each segment and you set it up and customize it and walk away.
Now, typically, would you say that the installation, the tech who sets up this system, is going to run through that with the customer, so that's all done right there at the beginning, or maybe come back in a couple weeks after they have a chance to work with it? How is that usually done?
So most of the time, you'll see that set up on install, or you'll see it set up. And to be honest with you, a lot of the jobs we do, even the residential ones, the bigger residential ones, they'll have the install crew and then the startup guy. And the startup guy is the one who doesn't do any piping. All he does is go to class and learn the option coding and values and changes. And he'll be the one that'll come out and change that kind of stuff on startup. And then they'll explain it to the homeowner. If you're in a building, a commercial building, they do the same thing. The installers come in, rough it in, set it up, pipe it, evacuate it, charge it. And then the startup tech comes in, turns it on, pairs it all up, and then sets the advanced options. So yeah, you usually do it right up front. And you can do it that way. Now, if you have one of those building management systems like an integrator and you've got the ability to log in from a laptop, you could do it remotely. But a lot of the homes, they're not putting in a backnet system or a digital gateway. They might be using like a Wi-Fi kit so that they can control it based on their smartphone. But using a Wi-Fi kit, you're not going to get into advanced installation setups like that.
Okay. And I'm assuming most people go with a Wi-Fi kit nowadays.
A lot of people are, and so we're seeing it one of two ways. If you go with a Wi-Fi kit, you usually have a specific app you have to use. Like if you use ours, you use the Samsung SmartThings app, and that's the same one that controls your refrigerator and your appliances and your vacuum and your TV and everything. Other people are going a different way. They're putting a thermostat adapter on the system for every one of the heads that allows you to use any thermostat you want to use, and maybe they're picking Ecobees And so they use the Ecobee app, and they have 10 thermostats paired to the Ecobee app. So you do it either way. You can use the Wi-Fi kit and use the brand software, or a lot of folks are using these thermostat adapters and then putting in whatever thermostat and app they like.
So, you work for Samsung, but I'm going to ask you this anyway. I would assume that you using the brand software allows more customization than if you use the aftermarket thermostat with adapter.
Yeah, because if I'm using the thermostat, really what I've got is I've only got communication between the thermostat and my phone. If I'm using the Samsung Smart Things and the Wi-Fi kit, I actually know how the outdoor unit's running, how the indoor unit's running. Yeah, you see there, I can control my lights, everything. So with like the Smart Things app, I can create automations that says at this time of night, turn on this TV, turn on this outdoor camera, set my thermostat to this, start the vacuum so the house is vacuumed when I get home, and have the TV come on at this time and to this app or whatever. So you can do that with it. And you have a lot more integration, but also with the Smart Things app, as the end user, if that outdoor unit gets a communication failure or a communication error or a superheat error, those numbers I was telling you about, the C101s and all those twos, the codes come through Smart Things. And the Smart Things app is continually diagnosing itself. So it's doing real-time diagnostics. So if you use the Smart Things app with Samsung, or whatever the software is for your Mitsubishi and your Daikin and your Fujitsu and your LG, you're going to get a lot more data. The challenge is the homeowner ready to use something that's more advanced like that?
Yeah, and will they use it for evil instead of good?
Yeah, and you know how
What
many
does this
homeowners
mean?
have
What
monkeyed
does
with
this
things
mean?
and you've had to change. Yeah, yeah.
Yeah, that's a line for questioning. I'm trying to bring up some of the HVAC parts of it. I don't know if I can find them. I see a couple little images here. I'm just going to bring up on the screen. Let me see. I don't know how applicable they'll be because I didn't have a chance to look at them very closely. But there's some of the examples of it, what it can do.
Yep.
Right there.
The other thing you can do with the Smart Things app is energy monitoring of everything in your house. And I think the next month they're releasing demand control, so that if you are in an area that wants to put one of them black boxes on your air conditioner to shut it down when the energy usage is high, if you're using Smart Things, instead of putting the black box, you tell it what you want it to do. And instead of turning off your HVAC system when the demand's high, it might stage down. So your utility company will still give you this huge rebate for using demand control, but you're not set to shutting your entire system off. You're just set to dropping it so that the amperage is low enough that it doesn't tax the grid.
Now I'm listening to all this advanced stuff. Next question: do you need to ever put gauges on this unit?
You know, I don't ever tell people to put gauges on the unit unless you're adding or removing refrigerant.
So only maybe at the very beginning, whenever you're commissioning the unit, you have to add some because you have to get the refrigerant in there somehow. And
Yep. And the only way you're going to put refrigerant in there, Zach, is to weigh in the charge. So let's say you're doing a multi-zone and you got 5 heads. You can open up the design software, which we give for free. You open up the design software, you put in your outdoor unit, you put in your indoor units, you go in and type in how many feet of each line set you have. Then the report comes back and says, all right, you don't have to add charge, or you have to add 7 pounds and 12 ounces. You hook up your gauges. I don't use my gauges. I use my probes, and I get my charging scale, and I hit 7 pounds, 12 ounces, or 10 ounces, whatever. Hit go, charge it in, and that's the last time I hook up to those ports.
Yeah, absolutely. What are you
'Cause
using field piece?
I am. I've been a field piece guy for 28 years.
I remember you doing the videos about them. I guess for the Toolbox series.
Yeah, when I used to
Right?
do the
Yeah.
Toolbox Tuesday, yeah.
Yeah, good old field piece probes. Yeah.
Yeah, so, I mean, but that's the only time, and the only other time we tell people to put gauges on them is if the charge is so jacked up, you don't know what to do, you don't know who's been there, pull it out, put it back in, but the gauges really are only there to add or remove. You don't use them as a diagnostic tool. I don't need to. I got pressure transducers throughout the entire system that tell me what saturation pressure is, what superheat is, and I know technically you can have a sensor go bad, But to be honest with you, a transducer that I've worked in, they don't go like out of range. They're open or they're shorted, no in between. So
Right.
like,
Right.
why hook up gauges and hoses if you don't have to?
So you don't see a transducer saying, "Oh, it's not 350 psi. It's actually 425." It's either it don't work or it does. Is what you're saying.
Yeah, and I mean, and you've had rare instances where they're out of range, but usually even when they're out of range, they're so far out of range, you're like, wait a minute, this thing's running in air conditioning mode. There's no way I can have an 82-degree evaporator coil. Right. So I mean, they're pretty straightforward. Like I love what T-Lex said here is you never need gauges, only a single hose to vacuum and add refrigerant. And that's true. That's all you ever need.
Yeah, that's what it sounds like. Sounds like if you add gauges, you're complicating your life unnecessarily.
Yes, and as soon as you add a gauge, you're running the risk of mixing in air, mixing in nitrogen, the wrong refrigerant, or in some cases, what can be even worse is the wrong oil. Most people don't realize that most of your mini splits and VRF systems don't use POE. They use PVE for a completely different reason. If you're using a POE oil loves to drink water and you can't separate them. PVE oil, I can remove moisture out of PVE oil all day long. POE, you can't.
Okay, so we're talking polyvinyl ether. Is that correct?
Yeah,
Polyvinyl ether.
polyvinyl ester oil.
So why do you use PVE? Besides, is just the advantage of it's not as hygroscopic, or it doesn't? Does it not hygroscopic, or does it not break down into acid? Which one is it?
You got kind of both with PVE. One, it allows you to remove the moisture. And then if you remove the moisture as a byproduct, if you don't have liquid water in the oil, you're not going to get the hydrochloric and the hydrofluoric acids that form when you have moisture and then temperature differentials. So the biggest thing is you can actually hook up your vacuum pump to a system with PVE and pull the moisture out. And we see guys getting down to, 75 microns, and they're getting all the moisture out. Where if you've had a POE system that's been wet, it's the system's been open to atmosphere. The guys put the gauges on wrong. You can run a vacuum pump forever and not get to those low values. So, I mean, PVE has a huge advantage, but the problem is if you're not charging right and you're getting liquid refrigerant in your hoses, and then you're not bleeding that off in the truck, and you're injecting large amounts of POE into a PVE system, it's just not going to be long. You're not going to have the longevity you want.
So is PVE just newer? Is that why it's a newer improvement? Why wasn't it used? Well, why is it not used for unitary systems now?
To why unitary's not using it, I don't really know. I don't see a reason not to. I know that PVE was also formed overseas. It was created overseas by, Big D and all those other brands there, right? So it was created there, and maybe it just never has been adopted. I don't know. I know that POE oil was used pretty quickly. They grabbed it right away because it's been used in jet engines for years in the military. So they knew it. They knew its miscibility. They knew its weight. They knew its viscosity. They knew it when it broke down under certain temperatures because it's been used in the military. The difference is when you're changing the POE oil in a military jet, you've got a pump and pull system. You're not letting atmosphere in. You've got a pump that's injecting and rejecting. So you got the ability on the military side to control the moisture. And your video today with those hoses leaking, right?
Mm-hmm.
Look, and the color red still looked like a pretty vibrant red, but it was leaking. So with POE, you always have that opportunity, right? PVE's been around for decades. T-Lex coming up. PVE is more heavy duty and it's a higher RPM, has a higher viscosity, so it doesn't break down. It doesn't break down at 220 degrees or 200. Yeah, it's 220 degrees is where you see most POE oil start to lose its lubricity. PVE can handle higher temperature differences without an issue. So it's a heavy duty oil. It's a little bit more costly, but I think the cost has come down. And in the unitary world, sometimes we're fighting over a nickel per unit. Maybe that's it. I'm only postulating at this point. I don't know the exact reason why unitary hasn't grabbed it yet.
I'm going to go with cost, probably.
Yeah.
I'm going to guess cost.
I wouldn't
I
doubt
think
it.
it was costly because I remember asking years ago when I first heard about PVE oil because it wasn't these mini split style systems they were using PVE. And I was like, why aren't they using it elsewhere? And I remember a wise, learned individual at the supply house said it costs a lot. This was years ago, so I'm sure that's what it all revolves around. Now, when I think of PVE, I was thinking about alternate refrigerants. What's the wave of the future refrigerant for Samsung?
We're still hunting. We're still trying to figure it out. We are doing our best to not have to use an A2L unless we have to, but we're playing around with it. In Europe right now, they're testing R32 because
Mm-hmm.
that's what everybody's trying to lean to, but we haven't shored up one on that yet. We've still got our folks working with Congress right now to look at legislature and see where they're going, because we got to be concerned about flammability rates, but also when you start using like an R32, which has a higher flammability rates, you start running into issues with ASHRAE standard 15, which is how much refrigerant concentration can be put into a space.
Mm-hmm.
If that refrigerant's higher flammability, you can put less of it in a space, which means that you need to have bigger square footages per air handler. And then, so there's just a lot of variables floating right now as to where we're going with it. And I know that one brand has jumped on R32, and that's because they
Mm-hmm.
invented it. But we've not made up our mind on it yet. We want something that's going to be effective. It's going to be environmentally friendly, but we don't want our techs to have to struggle to make the transition.
Absolutely. I do want to say, because you mentioned that, and I know I had the book sitting right here, something I read a few months ago from our buddy Jason Objute, Low GWP Refrigerant Safety. And that is an ESCO book. And it was really good. I read that if you want to learn about mildly flammable refrigerants and more, because they go all the way up to, I guess it's A3s, propane, butane,
Yeah.
and stuff like that. And I know there's one, say, futuristic refrigerant that was an A1, but I can't remember what it is. It's I think it had a higher GWP, and it was like barely under the proposed, or not proposed, but expected limit of 750. I think they're expecting it to
Yeah.
be around
Okay.
750, and it came in like right at that. And I know carriers going to a mildly flammable. Now I can't remember any of the numbers offhand, but it's interesting because I know R32 is really popular with the big D. I don't mean Dallas,
Yeah.
and some of the other brands. And then there's I cannot remember. Maybe it's 454B is the one. I can't
I
remember if
think that's
that's
the one Carrier grabbed a hold of. Yeah.
as of 2023. I think they're going to start using that. And I think that's still mildly flammable. And then there's another one, and I want to say maybe that's, I don't know which one's the Chemours one. One of them's a Chemours, one of them's a Honeywell. But I think the Honeywell Solstice one, maybe it's N41 is the brand name. It's
Yeah.
actually non-flammable, but it has a higher GWP. So you guys have your work cut
Yeah.
out for you figuring
We
that out.
definitely do, because there is that balancing act between hitting that GWP number and then, you know, making sure it's a safe range. But I'm not going to start posting any views here, because I remember the hassle we went through when R22 needed to phase out, and there were still stories about if it was really needed or not. I get it, but we got to do our part. But we got to make sure whatever we do, it's got a longevity. We don't want to have to. I mean, the way I look at it, we don't want to have to come up with a refrigerant now and in 10 more years change it again. We want
Yeah.
longevity with whatever we do.
It feels like that's going to happen. That's what it feels like, just because now there's multiples. Before it was like we have R22. Okay, we're going to 410A. They give us the reasons why. Okay, now there's multiples. So with multiples, you kind of wonder about the variability of the future and how many
Yeah.
jugs are going to be on the van, which I know annoys most service techs. Is I don't want to carry a million jugs of refrigerant, then a million recovery cylinders, unless I'm
Yeah.
going to mix them all together and take it there and go, I don't know what happened. Uh, it's just
Yeah.
going to be tough.
Especially now, since all your refrigerant cylinders are going to be gray.
Oh my gosh, I
Yeah, I
wonder
hate
about that one. I, I have no idea why that happened. I'm sure there's an explanation somewhere about that. I don't know. It's not for us. That's for sure the reason why. I have no
Yeah.
idea. Oh, it's good grief. That's nuts. Let's see. Let's see if we have any other questions here, because I know we're coming up on an hour and a half. We're really rocking and rolling. And let me see. Any questions, guys? If you're in the chat and you have a question, you can go ahead and put it in there. I'm going to scroll back here. Easy Heat and Cooling doesn't want to buy those probes. He's using his analogs. Don't put the analog on the VRF. It'll reject it like a bad organ. Let's see.
That's right.
There was Hughes man. I think I glossed over his question earlier, and he was asking more along the lines of, if I recall, how did you get into the position you're in? Because he was interested in transitioning, I think, probably out of the field into one of those positions. So maybe you should answer how you got to Carrier, because that was your
Yeah,
first
yeah.
step in that direction.
So I started as a maintenance tech, and I was doing maintenance while I was going to school, which was amazing because then the teacher would teach something the next day, I'm looking at it, right? So I had a really, really slow, quick learning curve, um, because I was learning about it and then doing it, learning about it and doing it. And I won't lie, Zach, there were probably a few of my maintenances that I spent a little extra time on because I wanted to learn, I wanted to try what I did in school. But it was cool.
Sure.
It was really great. And then when I graduated, well, by the time I got to third semester in trade school, I was already doing service work. And at that time, I had switched from a small company that was doing just residential, and I moved on to a company that was doing refrigeration, plumbing, electrical, a full mechanical contractor. And they were a Carrier dealer. And so we sold everything Carrier, from our Carrier window units. And I think the largest we went up to was about 120-ton rooftop unit back then. And it was all Carrier. And I was the service guy, the startup guy for all of those. And what happened is I love this business. And I started making sure that anything and everything that I could know, I knew. And I would go to every class and take every note, jot things down, start using it out in the field. I'd always be aware of the tools that were out there and find the newest tools to make me more effective. And what happened is, as a Carrier dealer, I would call Carrier tech support at the beginning, like, hey, how do you do this? And they'd walk me through it. By the end of it, it was like I was calling Carrier tech support and saying, hey, your unit's broken. Okay. And they're like, well, why? Well, because your superheat's this, your subcooling's this, your amp draw's this, your static pressure's this. And by the time I got to that point, usually the tech support guy was like, Jose's calling, he's got an issue. Right. And then that happened for so long that Carrier was like, wait a minute, you ever thought about coming out of the field? And at that point, my knees were getting kind of sore, and, I was feeling it a little bit, but I was like, I'm still young. I could do this. But that opportunity came, and I thought, you know what? Instead of being a service guy for the Southern California area, I'm not going to be a service guy for all of California. I'm going to go be the service guy for Oregon, Nevada. And I'm like, okay, I'm going to see a whole bunch of different type of AC systems that I've never seen before. So I took a job as an inside tech support guy for Carrier. Did that for a while, became the field guy. So I'd be the one put on a plane, dispatched to solve the world's problems. And, you'd find almost every major problem you'd ever see was an installation issue or a clearance issue or a whoops, we put the wrong valve in or something like that. And that's how I got there. And then from doing that, I started teaching classes, and I had some guys who worked for Lennox dealers that came to my Carrier classes. They liked the way I taught. They talked to their bosses talked to Lennox, and then Lennox recruited me away from the service side to just training. And then I got to tell you, once I got to Lennox, I put 10 years in with Lennox. They really are focused on training, and they spent so much time developing me that it helped me get to where I'm at now. So kind of the long journey to get there, but it all just starts invest in yourself every day. We all have a goose that lays a golden egg. It's called our career. If you don't feed the goose, it's going to stop laying eggs. So just keep investing in yourself, and then those opportunities will come.
Always moving forward, are we?
Yeah.
What's the next step? Samsung's not listening. You going to Daikin?
No, I think I can't think of a different brand right now. I think because I'm still only in year 4 of VRF and I'm still mesmerized by it. And what's really crazy is, I see guys jumping from VRF brand to VRF brand, and that happens, right? And it happens in unitary too.
Mm-hmm.
But what I see about VRF is what Mitsubishi's doing today, Samsung does tomorrow, and then Daikin does the next day, and then Daikin comes up with something and we all follow suit. So it's a small world. I think I'm just so happy training. I think that's where my niche is. I could honestly see myself training until I decide to retire. And then I think I might go backwards. I think when it comes time to get out of training and having such a big, heavy duty, responsible job, I think I'd be happy going back on the phones and going out in the field and helping guys out in the field.
It would be fun. It's always fun
Yeah,
to go out in the
kinda,
field.
yeah, it really is. It really is,
In a measured way, not
Yeah.
24 hours a day, but yeah, I understand. Lizaraga says, "Are there any classes Samsung are giving these days about VRF?" Hey, man, you just took one kind of informally with Samsung.
Yes. So there are definitely definite classes for us, and okay. First off, foremost, I don't want to seem like I'm doing a shameless plug, Zach, but it's the only way I know how to do it. All of our classes are always free. They always have been, and they always will be. We don't charge for classes.
That's disgusting,
Like,
Jose.
I just I put that into play when I got there because I'm like, why would I ask a guy to pay money to buy my equipment and then charge him to learn how to put it in? That's just ludicrous, right? So all of our classes are free. If you want to know about our classes, go to our website, samsunghvac.com, click on the training tab. From there, you'll see training, and you'll see that we have a system called Samsung Business Academy. Register for a free account. All of our main classes we offer as online classes that are self-paced. Yeah, right down there. If you go to the icon on the lower left, you'll see the pencil and paper. That's how you register for an account. And once you register for an account as a contractor or a partners are our people who sell the product. You register as a contractor. Within 48 hours, you'll get an email with your username. You log into Samsung Business Academy. You'll see a calendar of all our live classes and where they're being held. And we have live classes all over the US and Canada because our partners are training as well. Or you can take them online. And when you take our online classes, instead of being like one 16-hour class, it's a bunch of little modules that you can watch, a 30-minute module, and you can watch as many of those little modules as you want till you complete your training and get your certification. So what I've been doing over the last 4 years is any class that we teach live, I'm making an online version so that no matter where you are, when you are, and when you want to train, you can get training because that site it's 24 hours a day, 7 days a week. It doesn't sleep. So those training modules are always in there. Log in and get an account. And if you are having any issues getting an account, can I chat my email address in here for anybody who wants to know it, Zach?
Yes, you can. I might have to approve it. I tell you what, I can put it in the chat because it might stop you from doing it because you are not the moderator or something. You know how it is.
Okay.
Let me see if I can get it because I'll go to my email and go ahead. It's the one that I sent to you, correct? Same one?
Yeah. If you could share that with the audience, and if anybody's having a problem getting their free learning account, just email me, and either myself or one of my training coordinators will get it squared away.
All right, I'll have that in the chat in just a moment as I copy and paste. And here we go with a paste. All right, there is, and actually I can probably put it on the screen as well. Just give me one moment on the fly here.
Yeah, the only problem they'll have emailing me is they'll get a finger cramp by the time they finish typing it, but
yes, finger cramps, you just got to deal with it. That's what it
right.
says. So it's for people on the podcast, it's jd.portilla@samsunghvac.com.
Yeah,
and he will answer.
And I check that pretty regularly. It might take me a couple days to get back to you, but the thing is we'll get you an account. And you know what? I'm not going to try to say one brand or another. I'm going to tell you this: if you take a Samsung training course, you're going to know probably 90% of the brands, with the difference being the Mitsubishi, which is the 2-pipe. They do things a little bit different. But I mean, what I'm teaching you and what my brand is teaching you is going to be the same for the most part, with a few nuances, right? How they program something might be different than how we program it. But piping, diversity, load calculations, all those things are the same from brand to brand. I mean, it's just our little nuances that change things.
Absolutely. If Jose doesn't answer your email, then you email me, and I'll email Jose and say, "What's the deal, Jose?" And then he'll email me back and say, "I was out of town, leave me alone," or something like that. Or like Jose would probably say, "My kids had like 50 activities this week. Don't even worry about it. I'll get to it."
The other thing that I'll tell you guys too, if you guys are at a company that's not doing VRF right now, go somewhere and get VRF training. And then, you know what? Be proud of yourself and post that bad boy on your resumes and let people know you know what VRF is, because more and more contractors are facing it because they have to. And if you've got training before you have to do it, you're better off, right? So I'm always about investing in yourself, right? And so just keep it going, but get that training and get it on your resume, right? Get it on your profile so that either you're more valuable to your existing company, or if you decide that you're moving, you're valuable to the next company, whatever. I mean, I'm not telling anybody to switch jobs, but look, if you know more about something and your current employer decides to pick up VRF or mini splits, you know what you're doing.
And you're valuable. And
absolutely. It's
that's
all
very
about
good.
building your own brand.
Absolutely. Yeah, it's hard to get rid of somebody when he's the only guy that knows how to work on something.
Yeah, and T-Lec brought it up, a really great point again. Thank you. He said, once you start adding building automation to a large VRF system, you just jump to a whole new level, and you are absolutely right. And if people are looking to diversify or find new levels to go to, I'm telling you right now, the world needs controls technicians. And once you learn controls, you open up a whole new door for yourself.
Yeah, I feel bad because I just changed contactors.
We'll get you there, Zach.
Yeah, I'm getting there via podcast. I'm just looking, I don't know if I'll say looking forward necessarily, but like I said, I always work on some real simple stuff. It's been my whole career. It's where I live. I live in the country too. There's not a whole lot of VRF stuff out here, but there'll be a day and that it'll pop up because it's very popular now. Like I said, I have VRF outside, so someone else can afford it for sure if I have one outside. And I've seen a few of the Bosch units around here, and I've seen mini splits on people's garages. And now you're finally seeing like the whole house with mini split heads throughout, like the variable heads. So they're very popular now.
Yeah, I tried changing mine out, but when I told my wife I wanted to rip out my 4-year-old air conditioner and put in a VRF system, and I showed her the price tag, she stopped laughing in about an hour and then walked away. So, you know, it'll be an eventual thing. It's a 10-year plan.
Well, that's very difficult. What you got to do is you have to lean on Samsung, Jose. This is my method here. Just, you know, it's like, guys, you know, that Fujitsu is looking pretty good. They need a guy. So I need a system I can take to the house or something. And then when they like fire you, it's not my fault. I didn't tell you how to do it. But Jose, I know we've been a long time here. We're gonna have another show. We talked previously about doing various shows. I have the notes here that we originally when we had our talk a few weeks ago, and I had our notes here, but we had a whole lot of things we were going to do, including the one that really popped out at me, like the myths about VRF. That's something you might see in the future, or just like Thomas Lex said, could be something about the next level of VRF. We've had a nice broad conversation. Maybe we'll talk about how you take it up one more notch, integrate some of those other controls. So,
sure.
But as for tonight, I think we're coming to a close. I have a few other things I have to do. But Jose, I'm gonna thank you and let you get back to your life.
Thank you so much, Zach, and thanks everybody for joining. This is a lot of fun, as you can tell. I love talking and I love having the chance to work with y'all. So seriously, use my email if you need something. Let me know.
Jose, I appreciate it. I'm gonna let you go here, and I'll talk to you soon.
All right, thanks everybody. We'll talk to y'all later.
Thank you, Jose. That was Jose de la Portilla. Man, he's a smart guy. A lot of fun to have on the show. He's been on here before. I think this is the first live one. I think last time was a podcast. So he had a lot of great information. Guys, he's right. I myself have been afraid of some of the technology here for a long time. You know it. I say it a lot because I like to be forthcoming about my many flaws. So that's one of them. But I feel like every time he comes on, some of the fog dissipates, and I'm grateful for that. Now, I know you guys have some questions that you've had for me concerning the sweating on the Bosch and stuff like that. So what I'm gonna do is I'm going to take a little break here because I have a nice little cool thing that Yellow Jacket sent me that I'm gonna do a short video on. And we're gonna watch here real quick. It's kind of a cool core remover tool, and then when we come back, I'll answer some of those questions and we'll have some parting words. Guys, Yellow Jacket has just released a new tool that's going to help us with Schrader valves and issues with Schrader valves and just in general Schrader valves. Let me show you what I mean real quick. This is the Yellow Jacket HVAC Service Tools Real Torque 1/4-inch Superheat Kit with Torque CRT, part number 69111. Let's take a look inside the box. What we have here is a couple different pieces. We have this piece right here, which we're going to learn is a Schrader extractor. If we have a damaged Schrader, it's reverse threading, and it'll grab the Schrader and get it out of the port. Here, we actually have just a regular Schrader tool, as you can see on the end, but it's real torque, meaning when you get to the proper torque setting for putting in a Schrader, it's going to click, and not let you over tighten a Schrader, which is going to be real useful for guys like me, because sometimes I go overboard tightening gauge hoses and Schraders, and it can ruin gaskets, or worse, I might have to come back and use this tool if I'm in control of it. So then we have this, and I'm going to show you guys. This right here is a re-threader. So once you remove a Schrader, if you have damaged threads or damaged threads in general, you insert this into the tool and you actually thread it on and create new threads for your Schrader. So it's a pretty cool little kit, and I haven't forgotten here we have obviously a thermometer. You can actually check refrigerant temperature in the stream of refrigerant, which is something that's been around for a long, long time. In fact, I remember working on Linux package units, commercial ones, and probably residential too, had this. They had little wells so you can measure temperature of refrigerant directly. Now, we might do a little test and see if this makes a difference between this sort of measurement and a measurement from the outside of the pipe. So that is the 69111 from Yellow Jacket. You guys can check that out at your local supply houses. I'm sure you can get it online as well. Just a really cool kit that has a few different features which you may or may not use. You might have never used a superheat thermometer that's in the refrigerant stream, and you couldn't be more accurate than that, you would think, because it's actually touching what you're going to measure, not the outside of the pipe. So you don't have any loss of or transfer of thermal energy because the pipe is being heated by the sun, or we need to have an experiment, I think. But really cool tool with a lot of great pieces. So that is the 69111 from Yellow Jacket, which is the Real Torque kit with a re-threader, a Schrader extractor, and a superheat thermometer that inserts into the refrigerant stream. So what I think I'm going to do is I'm going to actually get that superheat tool and compare with like just a regular pipe clamp or something to see if there is a lot of variability. Because you figure, I mean, there's a lot of, and I know some of the pipe clamps, they take into account some of the external heat sources. Like if you have a pipe clamp that's sitting on copper and you have refrigerant on the inside, copper, obviously, thermal energy passes through copper pretty easily. That's why they use it. But there might be a small difference. If it's 1 or 2 degrees different, it's going to affect the superheat and stuff like that. So I'd like to figure out why. I'd like to figure out what's going on there. See if it's how accurate it really is compared to those. So I know a lot of us have some like K-types. We can compare K-types. I know there's like the Cooper-Atkins type. I don't know the names of all the different types of sensors, but it'll be neat to see it all in action. And I have that. It's still right down here somewhere. I'm not sure. Sometimes I give these tools away and sometimes I keep them. I might keep this one for a while. I've never had to extract a broken Schrader in my whole career, which goes back a long way, which I guess I feel pretty lucky. I've had some that there was issue with, so I took the valve core remover and opened it and shut it real fast and shot it across somebody's yard to get it out of the port. But I've never had to actually try to unthread one with that reverse thread device. But it'd be kind of interesting to have, and definitely useful in a circumstance where you might have to, I don't know, even change a valve or something, service valve or something if you couldn't fix it. Interesting, pretty cool tool. So that was 69111, I think, and that's Yellow Jacket, one of our sponsors. That's why I see it. It's a sponsor thing. Okay, so we had questions about the Bosch. Let's see. I saw it somewhere, and it was about the sweating on the Bosch. Now, I haven't, here we are, easy heat and cooling. The sweating on the Bosch, I haven't, like, completely 100% figured out what it is, but my current opinion is that it backed up, the drain backed up early on. The drain backed up, it flooded the cabinet of the air handler, ruined the insulation. So now every time it gets a really high TD from the blower side of the air handler past the coil to the outside of the attic, to the attic, just TD across there, that it's going to sweat because that insulation's ruined. And I saw no evidence that the drain was backed up the last time. It's almost like the sweating, and it was really profuse, but it would have to be really, really profuse to fill a drain pan. So, because, up in the attic, it's so hot, it'll evaporate after a few days. Because when I sucked all the water out, I left like 1/4 of an inch. A few days later, it's gone. So that's the one doubt I have, because it seems like that wouldn't be enough water. My solution, which I will one day put into effect, is I was thinking about getting one of those styrofoam insulating boards like you see at Lowe's, like a half-inch board or 1-inch board or something, and put it underneath the body of the air handler. Just cut it to fit the bottom of the air handler. Just set it on top of the blocks with the air handler on top of it to see if that extra thermal barrier will help it from sweating. That's my running solution. I don't know if that's going to work or not, or maybe that's not even the reason. The drain, compared with what was in the instructions had a slightly deeper trap than I put on, because I put a regular P trap in. A lot of guys were saying put a J trap in, and that would make sense. I think the J trap is actually deep enough. Having said that, I don't really think that's the cause of it, because the static is so low. We shouldn't have any issues with the blowers drawing a lot of negative static against the drain. I don't see that. Maybe that's just instinct, and I could be wrong, but I have a feeling that's not it. So, Easy Heat and Cooling says wrap it with ductboard. I didn't want to do something where I had to wrap the whole thing, where servicing it would become a nightmare, just because that's my frame of thought. I've been a technician for a long time, so I think that I don't want to make it like a nightmare to work on. I'm hoping that if I do the bottom, that's it. I've never seen any other part of it sweat, which makes me think that it was because the insulation was ruined on the bottom. I haven't seen the top, the back, or the front sweat, so that's why I came to that conclusion. And some of these, like the instructions say to wrap it with like 2-inch wrap or something like that. I forget what it says exactly. I do not want to do that. I do not want to wrap the air handler. That seems like a nightmare if you ever had to work on it. But theoretically, you shouldn't have to work on something for a long time. Ralph says should have done multiple returns. I don't know if that has a bearing on this, but there are 3 returns. That discussion all branched from the fact that there was a disagreement on how many returns should be in the house. I said I'm putting 3, 1 in each zone, so to speak. Think of it as I'm sitting in an area where there's 3 bedrooms and a den. That's a zone. And then the living room and kitchen's open concept. That's a zone. And then on the far end is the master bedroom suite, and that would be a zone. So there's 3 returns, and there's very low static. So I'm betting that the return on the far end doesn't get a whole lot of airflow because the other 2 are much closer. I don't know. I don't see how multiple returns beyond that would have solved the problem. I don't disagree that having the maximum amount of returns would be the best, but I think it's a diminishing improvement. It's so small and diminishing that that's why I didn't do it. And but you know what? It's for sure. I mean, if you have returns in every single room, it's hard to argue that it's not the best way to do it. It's just, I don't know. I say it doesn't improve much after a certain point. But we did have a problem. So, I don't know. Okay. So, I think that's all the questions I see. Working on Liberts, never done that. Never worked on a Libert before. I heard they have 407C. I like that stuff. But I've never worked on one before. Just residential, guys. You're watching a residential person. That's right. You're slumming it tonight with Residential Zach. That is correct. Oh my gosh. Non-VRF Residential Zach. And I thank you for watching, guys. It's really a lot of fun. I'm super glad that you watch. And if you don't mind, if you like the video, if you enjoyed it, of course, like the video. Subscribe if you haven't subscribed. We do this every week. It's been a little bit messed up as far as the schedule because I have been out of town. I know a couple weeks ago we didn't do one on Saturday night because I didn't feel like I was prepared enough because I was gone all week long. I like to have a little bit of preparation for the show. And I almost forgot to tell you guys, like the most exciting things that happened today. Oh, I was coming home, and this is single stage Zach talking. I fix contactors and capacitors, Zach. So I'm coming home, and we pass a yard sale on the way home. We're almost to the house. Actually, I had to come home because we're going to do this show. This is my life. I have to water some plants. I have to do the show. I have to feed a chicken. I'm not lying. That's exactly what I was doing. We pull by this yard sale. My wife's like, that looks like a really nice wicker cabinet. Do you want to stop? That's what I tell. Do you want to stop? I said, oh, I don't know if we have time. Okay, we're going to stop. That's what we're going to do. So we come back, we pull over, and I see a box full of like electronic stuff. I'm like, all right. Yes, this is great. This is great. Hey, what's even better is I can see Jose's kid down there. Yeah, I can see you down there. And what's funny is that he had his mouth on the mic. Yeah, I can see you, mister. That was hilarious. He's not on the stream. I'll say that, but I'm the only one that can see it. I can see everybody that's off screen. And Jose, you'll like this because I know you can hear me through the speakers still. Your son comes in there and he puts his entire mouth on the microphone. You definitely keep that microphone, Jose. But what I was going to say is we passed by the yard sale. We stop at the yard sale and there's a box of electronics. So I look over there and I see a computer monitor. I'm like, a computer monitor? I was just looking for a computer monitor. I had an old television as one of my computer monitors. That's right. That's what we're working with here, guys. I was like, this is a nice size computer monitor. So I bought that whole box. He says, how much? $20. So I got myself a laptop that has Windows XP on it. That's right. The best operating system. That tells you how old it is. I have a nice cord. It's like a VGA cord, I think is what they're called, and a monitor. And boy, I came home and slapped that thing on there, and it works beautiful. Had plastic still on it. $20. That's what we're working with here, guys. Okay, I'm going to get out of here. Had a lot of fun. I have some parting words here that I'm going to do, and I hope you guys listen to these parting words because this is literally the most important part of the show right here. Not taken away from anything that we learned, but this is the most important part. So I hope you watch the rest of the show, and I'll see you guys again next week. So I'm walking along here about 1.6 miles into my journey for today, and just wanted to talk to you guys. People keep asking me how I lost the weight, what diet it is, and I've lost just about 60 pounds from my maximum. I weighed in at 220 yesterday, and now I was at 278, so right about 60 pounds. And the secret is not a diet. In fact, the secret might sound like it doesn't even make sense to people. The secret is, it's Jesus, actually, guys. Just November of last year, I started dieting. I also started reading the Bible every day. And once I started reading the Bible every day and making a commitment to do that and try to take care of myself, the Bible puts a real value on life because Jesus came back just to save all the sinners that would just recognize that he was there to die. And he came down here sent by our Father in heaven to redeem all of us so we wouldn't have to go through this sacrificial system of the Old Testament any longer. There would be one final sacrifice of God himself in the form of a man who was put on the cross, died, resurrected. And at that point, he defeated death. As they say, death could not keep its hold on him. That's what it says in Acts. So he survived. He came back to life, thus making the promise true that through him, we could all come back to life and live with God forever. All we had to do was follow him, born again in the Holy Spirit. And that's something that makes me awful excited. And whenever you have that value put on life, your own life, the life of your neighbor, it really puts things in perspective. And you take care of your body because your body is a dwelling in the temple of God. And treating it like such, you take care of it. So that's really what happened. You may or may not believe that, but that's true. And I wish it for each one of you too.